పెన్ ఎక్కడ? Yes, good afternoon. So this is about the rectifiers. Okay, what is the rectifier input we are applying? The rectifier input. Okay, this is the rectifier input, and this one is this rectifier output. Okay, there is a bridge rectifier output. Now this, the output of the rectifier is this. This rectifier output, we are connecting to the filter input, the continuation. So we are constructed the bridge rectifier, and the bridge rectifier output we are deriving. So we got the pulsating DC. This DC is having AC plus DC. The two parts, the AC part is present and DC part also. The DC part means this one, that is a unidirectional. But here, the ripples, that is a AC component, some oscillations. Okay, so that oscillations, we need to remove that oscillations we are calling as a DC. Now we need to get the straight line. So we need to remove this. Remove the AC part. That output of the rectifier, we are connecting the filter. That is the C filter, capacitor filter. Okay. Before getting the C filter, we'll understand the another circuit, that is a full wave rectifier. Okay. So full wave and bridge rectifier. The output of the full wave and bridge rectifier is same. But how the full wave rectifier is works and what is the diagram of the full wave rectifier, we'll understand now. Okay, now connect the full wave rectifier. The difference between the full wave rectifier and bridge rectifier is the transformer and the number of diodes. So how many diodes we are using the full wave rectifier? The two diodes. The bridge rectifier, how many diodes we are using in the circuit? Four diodes. That is the D1, D2, D3, D4. How D1, D2, D3, D4 are works, we understand already. We are analyzed and we drawn the output waveform. Okay, same output waveform we can take. Now here we are taking the two diodes. Here we are taking the two diodes, that is the diode D1 and diode D2. But here we are using the different transformer. In the previous case transformer, how many wires in the output circuit of the transformer? 1, 2. But here, the 3 words. Okay, so here in between positive, negative, negative, positive. Okay, the waveform is appearing like this. If you are taking the transformer output at this point, and here that will be this. If you are taking this, the same waveform appearing like this here. అంటే ఇక్కడ పాజిటివ్ ఉన్నది ఇక్కడ నెగిటివ్ ఇక్కడ నెగిటివ్ ఉంటే హియర్ పాజిటివ్ ఓకే సో దట్ ఈస్ ద దిస్ ట్రాన్స్ఫార్మర్ ఈజ్ కాల్డ్ ద సెంటర్ ట్యాప్ ట్రాన్స్ఫార్మర్ this is the negative okay so the center tap this transformer the output of the transformer is having the 3 words that is 1 2 3 this transformer is called center tap tap transformer so now we are connecting this output of the D1 diode is connecting to this and here we are taking the output is here this is the RL and output we are taking positive and negative okay this is the circuit diagram for full wave rectifier what is the rectifier this is the full wave the previous one is bridge rectifier and this one is the full wave rectifier the circuit name is the full wave rectifier now this is the circuit diagram for the full wave for this also same we are applying the 230 volts input and 50 hertz frequency and this we are in the center tap transformer this is also step down so here plus minus and here minus plus reverse ikkada positive unte ikkada negative positive negative negative positive okay that is clear this between the 2 wires for this we are connecting the D2 diode D1 diode and D2 diode now coming to the operation first you can apply the here positive half cycle this 0 to pi what is the waveform positive half so for this positive half cycle the which diode can conduct and which diode can off which diode is on and which diode is off for the positive half cycle this is 0 pi here also 0 to pi the same waveform we are applying here but here the positive will become negative the negative will become positive now if you are applying the 0 to pi what is the waveform which peak we are applying here positive peak so the positive term is the input we are connected to the D1 positive then what will happen D1 diode forward bias if the D1 is forward bias then this acts as a short circuit this one is short circuit and what about this here negative half cycle negative positive what will happen reverse bias this is open circuit so now this can be acts as a short circuit and this can be acts as a open circuit now the circuit is open close or open now you can see entire circuit so here the input is here and this is the closed circuit output we are taking the closed but here this is the open so the which waveform will appear at the output side due to D1 for the D1 which waveform we are applying positive peak so now here this peak will appear because of D1 diode and here the D2 is off is it clear now so first half cycle is over now coming to this second half now again you can draw the diode here okay this is D2 diode and this one is the D1 diode now here which cycle we are applying now pi to 2 pi the pi to 2 pi here what's the waveform negative half so the negative amplitude so negative and here positive the D1 will become reverse and here positive the D2 will become forward so now for the second half cycle The D1 is the open circuit and D2 is the short circuit. This is the open and this is the short circuit. So here the positive off, which off is appearing at the output side? Here also this is connecting to here, positive, right? So which off, negative off or positive off? Because of this D2 diode, the positive off cycle, this positive will appear here due to D2 diode, and D1 is, and similarly here D1 and here D2 is on. This is the full wave simply. So what is the difference between the full wave and the bridge rectifier? Number of diodes and the transformer type. In the bridge rectifier, we are using the 4 diodes and normal transformer, normal and regular transformer. And coming to the full wave rectifier, only the 2 diodes, and this transformer is called center tapped transformer. Compared to the normal transformer, this center tapped transformer is the costly. Because of this center tapped transformer, the full wave rectifier is not recommended in our mobile phone adapters. They are using only full wave bridge rectifier only. Compared to the center tapped transformer, the diode cost is less. The diode cost is very, very less. That may be 1 rupee or 2 rupees. For the center tapped transformer, the 200 to 500 rupees. Which one? Center tapped transformer is the cost compared to the diode cost is the 1 or 2 rupees. That's, you can get the go to the market, you can ask the diode rate, you will get only the 2 to 5 rupees. But the transformer is the 200 to 500. To reduce the cost, okay. Now you can note down this circuit diagram, full wave rectifier. Now this output here, that is the full wave rectifier output, or the bridge rectifier output is same, and the remaining all parameters are same for the full wave rectifier and the bridge rectifiers. All parameters means there is a DC voltage, RMS voltage, and the efficiency, the ripple factors. Ripple factor ante how much AC component we are removing at the output side. That is called the ripple. Okay, efficiency. What is efficiency? What is the definition of efficiency? That is, the efficiency is the ratio of output to input. Now coming to our efficiency, to calculate the rectifier efficiency, it is defined as the ratio of output power to input power. What is the power? The power is the product of voltage and current. P is equal to V into I. Okay, that is the output voltage to input voltage. How much voltage we are applying and how much voltage we are getting at the output side. That is called the efficiency. Okay, so that all parameters are same for the full wave and bridge rectifier. Only the difference is the 2 diodes in the 4 diodes. That is the difference. And transformer is the center tapped transformer for the full wave, and for the bridge rectifier, normal transformer. The normal transformer cost is the less compared to this transformer. Note down this. Yes, note down. The circuit diagram full wave rectifier. Make it, everyone make it fast. Now this output we are connecting to, if you want the parameters, you can note down. Efficiency can be denoted as neta. What is the symbol? Anybody can tell me what is the symbol of this? What is the name? Neta. So that is efficiency of the rectifier is denoted as the neta symbol. That neta is 81.2%. Always you can represent the efficiency in terms of percentage. So how much percentage we are getting? Input దగ్గర 100 apply చేస్తున్నాం, output దగ్గర ఎంత వచ్చింది? 80%. That is 81.2%. But if you are taking the first rectifier half wave, దానికి ఎంత వస్తుంది? 40 points దాంట్లో ఆఫ్ వస్తుంది. ఎందుకంటే హాఫ్ వేవ్ ఒకటే అవుట్పుట్ వస్తుంది, ఇది రాదు. ఇది వస్తుంది, ఇది వస్తుంది, ఇది రాదు. అంటే absent అవుతుంది. నెగటివ్ ఆఫ్ సైకిల్ ఎక్కడైతే ఉంటుందో ఆల్ నెగటివ్ ఆఫ్ సైకిల్స్ ఆర్ ఆఫ్ in up here. In the out is the very less. So this is not the recommended. Of your rectifier is not recommended rectifier for the any circuits. Not only here, for the only to understand the knowledge, get the concept, we are studying the half wave, but there is no circuit using in the real life. Only the full wave one, anyone can be used, but recommended is the bridge rectifier in the mobile adapter. So after this class, if you are interested, you can design your own circuit also. That is the DC adapter, but don't connect that DC adapter to your mobile phone. You can connect to the any electronic gadgets. Better the shop lo dortuntayi kada, battery cars untayi. Idi 9 volts battery car. Dan place lo you can connect your rectifier circuit. If you are interested, you can design the same this circuit, and here I will give the filter circuit. That filter you can connect here. Okay, so this is the output of rectifier, and ripple factor can be denoted as this symbol, and that value is 40.6. The ripple factor is 40. Ripple factor is reduced. Okay, is over. Full wave rectifier. Now for the full wave rectifier output, we are connecting the filter out input. You can remember. Okay. Now regulator, sorry, filters. The filter is here. You can take the filter block here. Filter we are connecting. Maybe many types are there. So here we are connecting FWR output as a input. Okay, actually this is the input. So which input we are applying? Full wave rectifier output we are connecting to the bridge rectifier, sorry, filter, and the filter gives the pure. So here in this we are connecting AC plus DC as a input, but the output we are getting pure DC. Okay, here we are getting the output. Okay. Now draw the circuit diagram. Here same full wave rectifier output as a input. Okay, what is the output here? We are connecting the full wave rectifier. This. What is the property of the capacitor? For it allows the AC component and it will block DC. You can remember the capacitor property. What is the symbol? This positive, negative. What is the capacitor? Capacitor allows AC blocks DC. The capacitor allows AC component and it blocks the DC component. But the capacitor input, we are connecting AC plus DC. Both we are connecting as a input to the filter. Simply filter circuit, capacitor filter. Okay. Now, here, what is the output waveform? I will draw the output waveforms, the same output here. Okay. Now, and another property is if the capacitor allowing the AC, whenever the AC voltage increases, the capacitor will start charge. Capacitor, the voltage across the capacitor increases, the capacitor will get charge. How much voltage you are applying to the capacitor, so the capacitor will charge up to that large value. For example, if your starts from 1 volt, the capacitor will charge 1 volt. If you are applying the 5 volts maximum, so capacitor will charge up to 5 volts. If the capacitor voltage, that is the voltage across the capacitor is decreases, 5 tarata enti decrease avutundi kada, 5 4 3 2 1. ఇక్కడ ఎంత అమ్మా 0 1 2 3 4 5. Example. Actually 9 volts we are applying. Then 9 8 7 6 అంటే voltage decrease అవుతుంది, increase అవుతుంది ఇక్కడ decrease అవుతుంది, ఇక్కడ increase అవుతుంది. So whenever the AC voltage increases, the capacitor also will charge. Whenever the capacitor voltage there is a voltage across the capacitor decreases, the capacitor will discharge, but not suddenly. It will discharge slowly. ఎంత charge అవుతుందో fast గా అంత స్లోగా discharge అవుతుంది. Okay. Now you can see here we are applying the filter, the full wave rectifier output as a input to the filter. That is this dotted waveform shows the filter, the full wave rectifier output. That is a bridge rectifier output. Okay. Now here it allows the AC. Right? Now here we are applying the both AC plus DC here. Okay. Now here this capacitor allows the AC. How much AC is present here? That all AC is reaching the ground. ఇంకేముంటుందమ్మా AC allow చేసిన తర్వాత DC. So that DC will appear here as a output. This is the C. So here we are taking the output. So which one we are getting the output? This DC. Output is DC now. So how we are getting the output DC? You can understand now. Here 0, pi, 2 pi, 3 pi, and 4 pi. Now the 0 to pi, the voltage increase or decrease? Starts. ఇప్పుడే స్టార్ట్ చేస్తున్నాం. కెపాసిటర్ ఇక్కడ ఉంది, వోల్టేజ్ ఎలా స్టార్ట్ అవుతుంది? ఇలా స్టార్ట్. సో ద కెపాసిటర్ ఆల్సో విల్ చార్జ్ up to maximum value. What is the maximum value? This. After this maximum value, what is the voltage ఏమవుతుంది ఇప్పుడు? ఏమైందమ్మా voltage? ఇక్కడ 0 1 2 3 4 5 6 7 8 9. Then 9 8 7 6 5 4 3 2 1 0. Right? So the voltage is decreasing. If the voltage decreases, the capacitor will decrease slowly, not suddenly. The capacitor will discharge slowly like this. After reaching this point, again what will happen? Again the voltage is increases. So now it will charge up to maximum peak value. So after this again the voltage will decrease like this. This one. Now how much oscillations are reduced or oscillations are same? ఇలా ఉన్నాయి, తగ్గిందా పెరిగిందా? So now if you are drawing like this, then what will happen? The same waveform like this. ఇది ఇక్కడే రావాలా? స్ట్రైట్ పైకి రావాలి. what will happen? We are getting almost all straight line. That means the AC components are removed from the output. Okay, so that is called DC. So here you are getting the 90% DC current. If you want to get the pure DC, use the another techniques. In place of C, you can use the L filter, and you can use the LC filter. L means what is the L? Inductor. So you can use the combination of L and C filter. If the still it is present the AC component, then you can use the CLC filter, capacitor, inductor, capacitor. If you are using the CLC, the three components here, the almost all AC components is removed. Okay, but in our syllabus only the C filter is there. Okay, no doubt. Now the C filter is removing the AC component. Almost all the 90% AC is removed. So we are getting the DC straight line. Okay. Let's note down. You can note down. This is enough. This waveform is enough. Is not required. So after this, so the filter is over. So we are getting the first rectifier is converting the pulse both direction. That is a bidirectional to unidirectional. That is the pulsating DC. After pulsating DC, connect the filter. That filter is removing the AC part. That will use the DC. Now after DC, now we can connect the regulator. That regulator will use our required output for the mobile phone or any other electronic gadgets. Yes, make it first. For heading, you can keep C filter. C stands for capacitor. Which rectifier? Same. All parameters are same. Is the difference? ఇది డయోడ్స్ అంతే. ఆ కాస్ట్ గురించి మనం బ్రిడ్జ్ రెక్టిఫైర్కి వెళ్తాం. మీ సిలబస్ లో కూడా బ్రిడ్జ్ రెక్టిఫైర్. ఓకే. If you are having any doubt, you can ask me. And those who are in online, you can text in the chat box. If you are having the doubt, any online students, you can doubt, text in the chat box. Okay. How much voltage we are getting here? How much DC voltage? 0 to 9. The DC also 0 to 9 volts, right? The 9 volts it is not 0 to 9, simply 9 volts in the output. But our electronic gadget, but our requirement is to produce the output 5 volts as DC voltage. Output DC voltage. So we need to convert that 9 volts to 5 volts using regulators, that is voltage regulators. If it is over, then I will move the slide. Over. Now, for the regulator, what is the regulator input? What is the regulator input? The regulator input is the filter output. The regulator input is filter output. The filter output as a regulator input. Now, voltage regulator. Already we discussed the GNR diode. What is the special application of the GNR diode? Reverse bias. So the GNR diode is working in reverse bias also. And that reverse bias gives the constant voltage. Because of the property of the GNR regulator, the GNR diode acts as a voltage regulator here. Other than GNR diode, the many regulators are there. That regulators are 78XX series, 79XX series. 78 are the positive voltage regulators. the 7-9 are negative voltage regulators. IC name some of it. 78XX. Double X ante, what is the value of double X value? We don't know. So in place of this double X, you can keep 05. That is, what is the IC number now? 7805. That 7805 IC is the voltage regulator. That voltage regulator gives the 5 volts as output. Right? 5 volts. And if you are keeping X in place of XX12, for example, 7812. So that is 7812. 12 is the output voltage. So that gives the 12 volts as a output. That is a different IC again. If you want the negative supply, then you can use the 79 series. 78 series is the positive and 79 is the negative voltage regulators. And a negative 5 volts current, you can connect this. 7905 use cheste, that will give the minus power sub. That is, this gives minus 5 volts. Okay. Now, but we are not having that concept in the syllabus, but you can remember the 78XX and the 79979, and one more voltage regulator is a 723. 723. That is the variable voltage regulator. దీంట్లో మనకు ఫిక్స్డ్ ఉంటుంది. 7805 తీసుకుంటే మీకు 5 volts మాత్రమే వస్తుంది. నెక్స్ట్ 12 volts అవుట్పుట్ కావాలనుకోండి, దీన్ని కొత్త తీసుకోవాలి. అప్పుడు 7812 తీసుకోవాలి. అలాగే రెగ్యులేటర్ తో మొత్తం కావాలనుకుంటే 723. దట్ ఇస్ అ వేరియబుల్ వోల్టేజ్ రెగ్యులేటర్. 5 అంటే 5 అడ్జస్ట్ చేసుకోవచ్చు, 12 అంటే 12 అడ్జస్ట్ చేసుకోవచ్చు by rotating the rheostats, potentiometers. Okay, now coming to the voltage regulator, here the GNR has voltage regulator. The GNR diode we are using as a voltage regulator. So in which biasing the GNR diode is acts as a voltage regulator? Reverse bias. So in the reverse bias, the GNR, what is the difference between the PN junction and the GNR diode? Because of the doping level. Doping level. So high doping in the GNR diode, the less doping in the PN junction diode. Because of that less doping, the PN junction diode does not work in the reverse bias. Simply that is the open circuit. But here the GNR diode in the reverse bias also that will work. Okay, that is in the charge circuit only. In the reverse bias also. Okay, because of that property, the GNR can be acts as a voltage regulators. Okay, now the voltage regulator input. What is the input? Filter. Filter output as a input. ఇంతకుముందు ఏంది, ఫిల్టర్ కి వీఆర్ కనెక్టెడ్ ద రెక్టిఫైర్ అవుట్పుట్. రెక్టిఫైర్ కి ఇన్పుట్ కనెక్ట్, ట్రాన్స్ఫార్మర్ అవుట్పుట్ వీఆర్ కనెక్టెడ్ ద రెక్టిఫైర్ ఇన్పుట్. రెక్టిఫైర్ అవుట్పుట్ వీఆర్ కనెక్టెడ్ టు filter input. The filter input we are connecting to regulator input. The filter output connected to the regulator input. So now we can connect here diode also you can connect in the reverse bias. This is the GNR diode. Okay, now what is the voltage we are applying here? This. Right? Here, what is the voltage? 0.9. For example, you can assume this voltage regulator in the reverse bias range is 2 volts to 200 volts, right? But that is the depends on the manufacturing of the GNR diode. Same level perigekodi, that reverse bias voltage will increase. Okay, now we can assume in this region you can assume just 5 volts. For example, we are taking the one GNR diode from the market. That diode gives the 5 volts. You can assume. So according to that 5 volts, the GNR diode is doped. Okay. So now the GNR diode output is 5 volts. Now how much voltage we are applying here? 0 to 9. 0 to 9 is the positive voltage or negative voltage? Positive. So here we are connecting the positive and negative. How much voltage we are applying? 9. But here the diode is connected in now the reverse bias or forward bias. Positive connected to negative of the GNR diode and the negative connected to positive of the GNR diode. So now the GNR diode is in reverse bias. In the input circuit, how much voltage you can apply? Voltage enta constant istunam, variable istunama? 9 volts is the constant. So but this GNR diode will works in the reverse bias and that offers the constant. 5 volts. So how much voltage you can apply here? That will be the reverse bias. The reverse bias Zener diode can offers the, simply you can see the VI characteristics of the Zener diode. Yes, the Zener diode, the reverse voltage VR, and here the reverse current IR. Okay, so if voltage increases, the Zener diode still in the, there is no current will flow. But if you are increasing the still voltage, then it will start the conduction. See, what is the meaning of this curve? What is the meaning of this? Voltage increases, but the current voltage, the applied voltage increases. That is the bias voltage increases, but the voltage across the diode is voltage across the diode will give only 5 volts. This is not the applied voltage. Applied voltage increase just to apply 9 volts we are applying. But at 0.5 volts, that starts conduction and gives the current increases. How much current is present? That whole current can be appear in the output circuit, but the voltage is constant. So because of that old output voltage constant at the Zener diode, then the Zener acts as a voltage regulator. So this is the constant voltage. చూడండి ఇక్కడ ఇది కాన్స్టెంట్ బట్ ద వోల్టేజ్ కాన్స్టెంట్. ఏ వోల్టేజ్ దగ్గర, ఈ వోల్టేజ్ దగ్గర ఉన్నాము, బట్ కరెంట్ ఇంక్రీజ్ అవుతుంది. ఇది కదా కరెంట్ ఇంక్రీజ్ అవుతుంది, రైట్? సో దట్ ఈస్ ద Zener diode. Zener diode as a voltage regulator. Write down. Simply this is called the Zener voltage regulator. So now our power supply design is over. Okay, the power supply, DC power supply. First we are taking the rectifier. We are not designing the rectifier. Okay, we are simply buying the transformer from market. So the transformer we are not designing. So the transformer, that is a step down transformer, that you can connect to the rectifier input. Rectifier we are designing, the filter we are designing, regulator we are designing, but not the transformer, right? So after this class, if anyone interested, you can try to practice this. You can do the hardware prototype. Yes, no doubt. Over. Make it fast. Simply you can note down this. So the output waveform ఏమొస్తుందమ్మా దీనికి? ఇక్కడ 9 volts ఇచ్చాము. అవుట్పుట్ ఏమొస్తుంది? 5 volts. There is no T. ఏమైనా వేరియేషన్ ఉందా? ఏమీ లేదు అక్కడ. D మొత్తం కాన్స్టెంట్. Okay, so that is the output voltage. So now after this our electronics part is over. So what are the topics we have covered? There is a semiconductors, different types of semiconductors. Using the different types of semiconductors, we are making the PN junction diode, right? After the PN junction diode, then Zener diode by increasing the doping levels. The Zener and PN both are two terminal device. That is the anode and the cathode. Okay, next coming to the three terminal device, that is the BJT. The three terminal device, that is a transistor, there is a unipolar devices and bipolar. We are designing the bipolar transistors. That is bipolar is bipolar junction transistor, BJT. That BJTs are two types, NPN and PNP. Okay, so NPN transistor we are taken in the PNP, simply electron place lo hole pettandi, the remaining operation is same. And battery direction కూడా చేంజ్ చేస్తున్నారు. అక్కడ పాజిటివ్ కనెక్ట్ చేస్తే ఇక్కడ నెగిటివ్ కనెక్ట్ చేయాలి. సో ఫర్ ద పిఎన్పి, సో పిఎన్పి యూ కెన్ అనలైజ్. సో we have discussed the NPN transistor. Okay, next NPN and PNP, then using the three terminals of the transistor, the transistor can be configured the three ways: common base, common emitter, common collector. Over. and input characteristics and the output characteristics we drawn, and in the based on the output characteristics, the transistor can be different applications. One is switch and amplifier. If the transistor is operating in the cutoff region, then that acts as a amplifier. Active region, sorry, the transistor is works under active region, that acts as a amplifier. If the transistor in the cutoff region, cutoff means both junctions should be off, reverse. That is the off switch. If in the saturation region, both are forward bias. If both are forward bias, voltage increases, current also increases. That means both are forward bias. So if the both are forward bias, that region is called the saturation region. In saturation region, the transistor acts as a on switch. Okay, other than the two applications, the transistor can be used in the mini integrated circuits, computers, wherever the electronic part is there, in that we are using the transistors. Okay. Now, coming to the next part. Okay, the next one, the digital electronics. See, in the first class, we studied the where we are using the electronics. Okay, so we discussed it and we are analyzing some topics. Now, digital electronics. So where you are finding this word in the real life, digital electronics. This is also electronics, but digital. What is meant by digital? Storage. Digital. Where you are using the word digital. Digital. Is it digital or analog? Digital. Computers. Digital. Monitors. Digital. That's digital or analog. But inbuilt inside of that one, that is having some smart watches, right? So these all are digital. Okay, forget about the all components. Again, remember the laptops or desktop. In C, I think everyone writing the C language program. Okay, I will tell you one program, simple addition program. Anyone can tell me what are the steps to write a C language program, and what are the steps are there, and how the computer will use the operation. Anyone can stand up and tell me? C language program, simple program, addition. Addition. C language program, simple program. How to write the simple addition program? First, you can initialize the variables. What are the variables? A, B, C. Now, before initializing the A, B, C variables, what you are writing? Yeah. No. For that variables, integers. So, what are the different? What is the integer name? Int. What is the category? A category lo internal. Data types. So data types, right? So the which data type you are integer data type or float or long or double, right? What is the difference between the int and float or double? Int, int can be integer. Okay, double, long ante long decimal. So what is the integer maximum value range? What is the integer size in terms of bytes? 2 bytes, 3 bytes, 4 bytes, 16 bytes, 8 bytes, 2 bytes. Okay, the integer is the 2 bytes. What is the mean by 2 bytes? What is the 2 bytes? How many bits for the 2 bytes? 16. Good. 16 bits. Okay, if you are using the 16 bits as a variable, then what is the maximum value for that 16-bit variable? 16 ante 2 to the power 16. What is the 2 to the power 16 value? 65,536. If you are having the calculators, you can find the 2 to the power 16. Why I am saying the 2 to the power 16? Why not the 4 to the power 16, 5 to the power 16? 16 is a fix because the 2 bytes. 2 bytes is equal to 16 bits. So that's why 2 to the power 6. Why not 4 to the power 6 or 5 to the power 6? Why only 2? 2 bytes. Okay. For example, 4 bytes తీసుకుంటా. Integer నేను ఏమంటానంటే 4 bytes అంటాను. అప్పుడు 4 to the power 16 తీసుకోవాలా, 4 to the power 32 తీసుకోవాలా. 4 bytes అంటే ఏంటి? 2 bits. Why 2 to the power 16?
Because
binary.
sir,
So that means the all variables and all operations performed in the digital computers is binary. What are the binary numbers? Zeros and ones. So the all operations, you can take the any operation, multiplication, division, addition, subtraction, any operation can be performed in binary numbers. But the binary numbers. Okay, so all the digital computers are using that numbers, only the binary. There is no decimal numbers in the digital systems. But we know only the decimal numbers, right? Do you know the 10101001 value? Anyone can tell me? 101010 value. That will take time. If you know the procedure. If you don't know the procedure, blank. Okay. So now, if you know the 232323, what is the value? 232323. 2323 ante 2323. We can say the value of that number, but 101010 we can't say. So the different number systems are there. The number system means the way of representing number using symbols or digits is called number system. How many symbols we are using in the number system, that is called number system. For example, you can take the decimal number system. What are the symbols we are using? ఏమమ్మా డిఫరెంట్ నంబర్స్ ఉన్నాయి. మనం జనరల్ గా నంబర్స్ మాట్లాడుతుంటాం కదా, అందులో డిఫరెంట్ నంబర్స్ ఏమేమి ఉన్నాయి? 1 2 3 4 0 to 9. You can take the any number, the crores or billion or any number. That is the combination of symbols only. Okay, so that how many symbols? 0 to 9? 10 symbols. So the any number system is having the how many maximum different symbols. Based on that, we are giving the name to that number systems. In our decimal system, that is called we are using the numbers. That numbers are called the decimal numbers. Okay, so in that decimal numbers, the different symbols are 0 to 9. Because of that 0 to 9, the different symbols are 10. 10 is also called deci. Do you know the deci meaning? Deci means 10. Okay, so the 10 different symbols are there. So that's why that is number system is called decimal number system. Coming to the binary, only 2. What are the 2? Zeros and ones. So any number can be written. That is the 2323. 2323 also can be written in terms of zeros and ones. Okay, that is having only the zeros and one numbers. Okay, that number system is called binary number system. How many symbols in the different symbols in the binary? 2. What are the 2? How many total? 2. 2 means by. That's why that number system is called binary. Okay, if any other number systems, for example, you can take the 0 to 7. How many symbols? 8. 0 to 7. So that number system is called octal. If the number system is having the 0 to 15, hexadecimal number system. So 0 to 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, see, don't take the different numbers, different symbols in the 2-digit form. The symbol should be single digit, 1 bit or 1 notation only. Don't take, for example, after 9, the 10 will come in the hexadecimal number system. So don't write the 10. The 10 equal to A. So according to that, we are having the different number systems in the digital electronics. Why we are studying this? Because of our digital computers are using only binary numbers. So we know that we want to learn about the binary number system and decimal number system. In between binary to complicated to convert. So that's why other number systems we are using, that is the octal and decimal. That is easy compared to binary number system to write and to understand. Okay. So the different number systems we are having. What is the number system definition? Number system is a way to represent number using symbols or digits in a consistent manner is called number system. Okay. So we are having the different number systems. One is okay, decimal, binary, octal, hexadecimal. Right? These are the number systems we are studying. And other than these 4 number systems, we can design our own number system also. There is no issue. After this, you can design your own number system. Okay. So now the decimal, what are the different symbols we are using the decimal number system? 0, 1, 2 up to 9. The total symbols are 10. So that's why this number system is called decimal. Okay. So the base of this number system is 10. This base, BAC, base, and this base is also called radix. Okay. So now the binary number system having the symbols are zeros and ones only. So these symbols are 2. Therefore, the binary base is 2. Okay. Now the octal system is having the number and different symbols are 0 to 7. That is a 0, 1, 2, 3. That is, and number of symbols are 7. The base is 8. And here the 0 to 9 symbols, and then A to F. A is the 10, B 11, C 12, D 13, E 14, F 15. So the total 16 symbols. So base is 16. These are the different number systems. Now you can take your own number system. Anyone? 12 number system, shall we take? 12. What are the different symbols are present in the 12 number system? 0 to 9, 10, 11. 10 can be written as A, 11 can be written as B. So 0 to 9 and A comma B. That number system is called 12 number system. So after studying these different number systems, we need to understand if the one number system is given, how to convert that number to our usual number system decimal. Or if you know the decimal value, how to convert this decimal value to binary or decimal to octal, decimal to hexadecimal, how to convert. We need to understand that conversions. That is called the number system conversions. So what are the number systems we are having? Decimal, binary, octal, and hexadecimal. You can remember. Now, write the one example for the decimal. Example is 239. 239. This decimal number system can be represented as base 10. This base suffix is called the base of that number system. Okay. Now the binary number system is 10101100. Okay, that is base is 2. Now here the number is 0, 2, 7, 1, 8 is the octal number system, right? Is it octal number system? See the number octal. What is the maximum symbol in the octal? 0 to 7. But the 8 is present. So this is not the octal number. If in any exam, if they are giving the octal number, name octal number ichi, value will actually simple write the one answer. The given number system is not octal number system because the maximum symbol in the octal number system is 7 only. So here in this given number 8 is present. So that is not octal number system. Simply that is the answer is enough. Okay. So this is octal number system. Next, coming to this 2AF6. This base is 60. So these are the examples for the to convert the one number system to another. Do you know this binary? We know. And this one decimal. If I am writing the 239, you can say easily 239. If I am giving the large value also, you can say, because we are learning from the UKG, the LKG onwards, the numbers, right? So we can say the any value. And we can assign the weight of, what is the weight of this number? What is the weight? 230 plus 9. What is the weight? This is the 9 units place, tens place, 200 place. 200 place means 200 is the weight, and 30 is the weight, and 9 is the weight. Okay, we know that. But how we can estimate the weight of that value and in the octal, binary, and hexadecimal? We need to understand by converting the one number to other numbers. I will take the one. I'll take the all conversions at once. Decimal. Now you can convert decimal to binary, octal, and hexadecimal. 16 table 16 8 ఎంత ఎంతమ్మా 16 8 120 128. Okay, now we can take the example 128. Okay, 125. Simple number I will take. The decimal number I am taken 125, 125. That decimal number you can convert to binary, octal, and hexadecimal. Blindly you can remember the number system conversion. If the input value is the decimal value, if you are converting the different number systems, first you can find out what is the base of that number system. What is the base here? 2, 8, 16. Now you can write the same decimal number here. Same decimal number here. Now we can divide with destination number system base. Divide with, what is the destination number output number system? We are converting decimal to binary. So what is the binary number system base? 2. So now we can divide with 2. In the division, if you are getting the any remainders, that remainders you can write separately. Okay. Now you can divide 2 125 2 64. So in this division, how much remainder you are getting? So that remainder you can write separately. Okay. So now here again to 32, the remainder is 0. Next to the 16 2s are, so remainder is 0. Next the 2, the remainder is 8, 8, remainder is 0. Number వేరే తీసుకుంటే సరిపోతుంది. Next 2 4s are, remainder is 0. 2 2s are, remainder is 0. 2 1s are, remainder is 0. Right?
Hello, sir.
Now this all remainders you can arrange from bottom to top. How the arrow is showing? So in that direction you can write the number. So now what is the value? The 125 equivalent binary value is, what is the value? 1 0.
That's 62.
Okay, now you can write T 62. Remainder is 1. Now you can divide with 2, 31. Remainder is 0. 2 31 ja 0. And 2 6 15 ja. And the remainder 1. 2 7 ja. Remainder is 1. And 2 3 ja. Remainder is 1. 2 1 ja. Remainder is. Now, if the quotient value is less than the base value, you can stop the division process. Whenever the quotient is getting the less than our base value, you can stop the division process. Now, this all remainders you can write from bottom to top. Bottom to top. So now what is the value? 1, 1, 1, 1, 1, 1, 1. How many ones? 5 ones. Okay. So now you can arrange all remainders in bottom to top. Okay, 1, 1, 1, 1, 0, 1. That is the equivalent binary value for given decimal value. Now, coming to the octal value, the same process. You can divide the decimal value with octal base and write the remainders separately. Then again, arrange the remainders in the bottom to top. Then that is equal to our decimal value. And similarly, hexadecimal. Everyone do it. Write the equivalent octal value for the given decimal value and the hexadecimal value. Those who are sitting ideal without writing, they have to do on board. What is the value? Octal? Do it. Board में निकलता हाँ मर्जी. Do it fast. Boys, anyone can answer for the octal equivalent value for the given decimal. So for this number system conversions, you have to know the 8th table, 16th table. 175. 1 4 45. 175 155 175 175 8 1 ja 8 1 ja 1 ఒక నిమిషం 1 8 5 ja. Okay, now 125 and 8 here. ఎంతలో అవుతుందమ్మా 15 50 15. Okay, next again 8 1 7. So the 125 equivalent octal value is right 1 7 8. Both are same. This value in the decimal and this value in the octal. Okay, and similarly you can do it the octal, hexadecimal, same. 125 and 16. Direct ఒకటేసారి వెళ్ళిపోతుంది. 125 7 జా ఎంత 112. So 125 minus 112. 13. Okay, so now you can write top to bottom. What is the value? 713. Right? 713 is the answer. Don't write the 13 as it is. 13 equivalent hexa symbol. What is the 13 equivalent hexa symbol? 10. A, B, C, D. That is 10, 11, 12, 13. A, B, C, D. This is D. So the answer is 125 decimal is equal to 7. 7D is the answer. Okay. So now, like that, if you are having the 12th number system, same process. You can divide with 12. Okay. So this is the conversion of decimal to any other number systems. Simple answer for this. The which decimal to which number system you are converting, divide with the base of that number system and write the remainder separately. After completion of the division process, all remainders you can write bottom to top. Kindi nunchi paiki. Okay, bottom to top. Now, reverse ela cheyali. Binary nunchi decimal lo cheyali. What is the process? What is the reverse case? I know the binary value. How to convert the binary to decimal? Multiplication. ఇక్కడ ఏం చేశాము? Mathematics లో division కి opposite multiplication. Multiplication కి opposite division. So ఇక్కడ multiply చేస్తే reverse వెళ్ళాలంటే divide చేయండి. ఇక్కడ divide చేస్తే reverse వెళ్ళాలంటే multiply చేయండి. Okay. So multiply with what? ఇక దేంతో divide చేశాం? 2 తో. Decimal to binary అంటే 2 తో divide చేశాం. Decimal to octal అంటే divided with 8. So decimal to binary convert చేసినప్పుడు binary to decimal చేయాలంటే 2 to the powers తో you can multiply. And similarly 8 powers తో you can multiply. And 16 powers you can multiply, you will get the decimal values. And addition is opposite in the mathematics, subtraction. Right? So now yes, hello. Right? Reverse process. That is the binary to decimal, octal to decimal, the decimal to decimal. Now you can tell me the binary value here. What is the value? 11101 is the binary number. Now we can convert this to decimal. And here the octal number we have taken in the last one is the octal. Now we can convert this to decimal. And here and the 7D. 7D we can convert to 16 is the base. Then you can convert this to decimal. 239 or 125 is the decimal value. For the decimal value, yes, 125. This 125 can be written as 100 plus 20 plus 5. This can be written as 1 into 10 square, 2 into 10 plus 5. 5 into 10 to the power 0. Right? Similarly, so now the 10, for example, 200 unte 200 kada 200 ni 2 into 10 square. So this 10 square is the weight of this 2. And this 10 is the weight of this 2. And this 10 to the power 0 is the weight of this 5. Similarly, the which number system you are having the base powers of that number system. So now what is the base value? What is the power value, weight value for this? 2 to the power 0. And this power weight value is 2 to the power 1. Similarly here. What is the number system? 225 decimal number system. So this 5, or you can take the 3, better. Okay, 325. So here the 3 into 10 square. 10 square is the weight. 10 is the weight. 10 power 0 is the weight. Similarly, here also same. Now this weight is 2 to the power 0, and this weight is 2 to the power 1, 2 to the power 2, 2 to the power 3, 4, 5, 6, 2 to the power 6. Now you can multiply and add with the weights of the binaries. Okay, so now what is the first number? 2 to the power 0 plus 0 into 2 to the power 1. The powers can be increased from right to left, similar to our decimal numbers. Next, 1 into 2 to the power 2 plus 1 into 2 to the power 3 plus 1 into 2 to the power 4 plus 1 into 2 to the power 5 plus 1 into 2 to the power 6. ఇక్కడ ఎంత ఉంటే అంత వాల్యూ. సో ఇక్కడ 0 ఉంది కాబట్టి 0. 0, 1, 2, 3, 4, 5, 6. Now what is the value here? 2 to the power 6 into 1. What is the 2 to the power 6 value? 2 to the power 6. 64. 64 into 1. 64 plus 2 to the power 5 is the 32 plus 16 plus 8 plus 4. 4 into 0. Okay, 4. And plus 0 into 2 to the power 1. 0 into 2 to the power, what is the value? 2 to the power 1 value is the 2, and 0 into 2, 0. Plus 1. Now tell me the answer. 64, 32, 96. 96 plus 16, 112. 112 plus 8, 120. 124, 125. Now you can convert this. Octal number also same. Octal to decimal. Multiply with the 8 powers. So that is 5 into 8 power 0 plus 7 into 8 power 1 plus 1 into 8 power 2. It is the 8 square, 16 plus 7 into 8. 8 power 1, 8. 7 into 8. Oh, sorry. 64 kada. 64 plus 56 plus 5. 8. What is the 8 power 0 value? 1. 1 into 5, 5. So the total value is 125. And similarly, 7 into 16 power 1 plus D into 16 power 0. The D is the 13. So 16 power 0 is the 1. 1 into 13 and 7, 16 ja 120 plus 112 plus 30 is 125. Okay, so this is the conversion of the decimal to different number systems and the conversion of different number system to decimal number system, right? Now, other than these number systems, these conversions, other number systems also there. Why we are using the octal and hexadecimal especially? Actually, the computer can understand binary values. The human can understand decimal values, but there is no need of studying this. But some computers are giving the output as a hexadecimal values because we are saying the integer. What is the integer size? You say someone said the 2 bytes. The 2 bytes means 16 bits. Okay, if the register is the 16-bit register. So in that case, that 16-bit data sometimes can be represented in the 4-bit format. అంటే ఒక 8 byte ఉంది, ఒక byte ఉంది కదా, బయటికి ఎన్ని 8 bits. That 8 bits can be represented separate as a 4 bits as the one group, other 4 bits as a one group. The first 4 bits are represented in the hexadecimal number format, and the second also can be represented as the hexadecimal format. So for that, we need to understand the binary to octal conversion, binary to hexadecimal conversions, or the hexadecimal to binary and octal to binary conversions also we need to understand how we are converting. Yes, no doubt. Simple conversion. అక్కడ divide చేసాం, ఇక్కడ multiply చేస్తున్నాం. Wait, for that you can remember this. 3 weight is the 10 square, and 2 weight is the 20, 10. The 5 weight is the 1, like that. So similarly here also same. This weight is the to the power 0, to the power 1, to the power 2. If you are coming to the octal, there is 8 power 0, 8 power 1, 8 power 2 with a particular value. In the exam, compulsory one question you will get on these conversions. So everyone do it. Don't skip this question. Simple question. Similar to LKG addition subtraction ఎలా ఉంటాయో ఇప్పుడు మనకి డిజిటల్లో అలా. You know the process. You can do it your own. I am moving the slide. This is a summarized table. The decimal to binary octal hexadecimal conversion, and binary to decimal octal to decimal, and hexadecimal to decimal. Now you can convert the another conversion, binary to octal and binary to hexadecimal. Yes, hello. The two intermediate conversions. If you don't know the 8th table, if you know only the LKG stands the 2th table. Okay, how to convert, how to get the equivalent hexadecimal value, how to get the equivalent octal value. Okay, so that is also possible. No need to remember the 16th table or 8th table also. By using this conversion, the binary to octal, octal to binary, binary to hexadecimal, hexadecimal to binary, you can convert that into decimal also. So one conversion is enough. That is decimal to binary, binary to. Now by using this intermediate 8. Octal base is 8 and hexadecimal base is 16. Now you can represent 8 in terms of 2 to the powers. What is the 8 equivalent to 2 to the power 2 to the powers value? 2 to the power 3. 2 to the power 3. Now 16 equivalent to 2 to the power value? 2 to the power 4. What is the 2 in our numbers, all number systems? What is the 2? 2 is the base of the binary number system. Okay. So now we are converting binary to octal, binary to hexadecimal. Now this base we are represented in terms of the 2 to the powers. This also in terms of 2 to the powers. Now, if you know the binary number, how to get the equivalent to octal value means you can group the 3 bits in the binary value as a one group. The 3 bits as a one group. 10 bits in 1 0 1 1 1 0 0 like that. Okay, now you can group first 3 one group, second 3 one group, next 3 one group, and last bits are one group. Okay. Now, for example, you can take the what is the binary equivalent value for that previous 1 1 1 1 1 1 0 1 0 1. This is the binary value we are taking as a example. That is a binary value. And for this binary value, this number is called LSB and this is called MSB. What is stands for LSB? Anyone? Tell me, what is LSB stands for? LSB is the least significant bit. That is also called rightmost bit. Right most bit or least. L and least and in the takko value. 238 which number is 8? 8. That is the units place. Next 3 is the tens place. 2 is the 100 place. So the 2 is having the high weight. Okay. So here also same. That is the least significant bit and the most significant bit. So while converting the binary to octal, you can group the 3 bits as a one group. That grouping starts from LSB side. Don't take the RSB. Don't take the MSB side. So now you can take here. What is the number? 1 1 1 1 1. 1 1. So in these numbers, you can take now this is the binary equivalent value. So in this binary equivalent value, 1 2 3, one group. And here 1 2 3, another. For the last one, only one is there. Okay, now you can add how many zeros you want, that many zeros you can add at the left hand side. If you are adding the left hand side zeros, the value remains same. Don't add the arrows at the LSB side. 238 undi. 38 ki left side oka 0 add cheste emaitadi 0 to 38 avutundi. What is the value? 238 only. If you are adding the right hand side 2380, that is the 2000. That will become 2000. So don't add the zeros at the right hand side. Always add the zeros at the left hand side. That value remains same. Okay, here we are converting the binary to octal, but we are not changing the value of the binary. Right? The same amount of value we are representing the octal. So for that, how many zeros are less? You can that many zeros you can add at the left hand side. That is the most significant bit side. Now, before this, you have to know what is the 101 decimal equivalent. What is the 111 decimal equivalent? You have to know. So now you can take the 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So this value is 0, 1, 2, 3, 4, 5, 6, 7. Wherever that symbol, that group is appearing in that place, you can change the value with the octal value. So the octals are the octal, these are the octal equivalent values. Octal equivalent values, the binary equivalent representations are 0, 0, 0, 0, 0, 1. That is the 1, and 1, 0, 1 is the 5, 1, 1, 0 is the 7, 1 is the 7. So now what is the value here? 1, 0. What is the 1, 0, 1 value? 5. Next, 1, 1 value? 7. Next, 0, 0, 1 value? 1. What is the total value? Now you can see the previous number, octal value. Octal value entama 175 kada. This equivalent enta idi 125 decimal value. 125 decimal value equivalent to binary value. Our binary value ki directly without doing the eighth division, eighth table division, we are getting the octal value by using binary to octal conversion. Now, how to convert the octal to binary? Octal to binary. Now, the each digit you can write in the 3-bit format. This is called the 3-bit format. So now 5 equivalent to 3-bit value is 101, and the 7 equivalent is the 111, and this one equivalent is 1. So that is 1, 3 ones, 101. The total value is, again we are getting this. That is conversion of octal to binary and binary to octal. So how to convert the octal to binary? Octal to binary. Each octal digit you can represent in 3-bit form. For example, tell me the 305 equivalent to binary value. The 305 is the equivalent. I want equivalent to binary value. Represent the each digit of the octal number in the 3-bit format. What is the 5? 1, 0, 1. Next, 0 is 0, 0, 0. Next, 3 is 0, 1, 1. That is the binary equivalent value. Okay. And similarly, coming to the hexadecimal number system, the hexadecimal base is the 60. That 16 can be written as the 2 to the powers. That is the 2 to the power 4. So now, while converting the binary to hexadecimal number system, in the binary, you can group the 4 bits as a one group. You can group 4 bits as one group. Okay. So now, what is the value here? And before that, you have to know the 4-bit numbers, all 4-bit numbers. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Sorry, 1 here, 1, 0 here. This is the 1. Next, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, then 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. This value is 0, 2, 3, 4, 5, 6, 7. And here 8, 9, A, B, C, D, E, F. These are the hexadecimal symbols, and each hexadecimal symbol, the binary equivalent values in the 4-bit format. Adi 0 nagani, you can write the 4-bit format. That is the 4 zeros. Okay. So now you can write what is the value? Binary value is 1, 1, 1, 1, 1. Okay. 0, 1. Now you can group from left hand side. That is the, sorry, right hand side from the LSB onwards. 1, 2, 3, 4. 1, 2, 3, 4. 0 is missing. The only 3 bits are there. You can add the one more bit here. Now 1101. What is the 1101 value? D. This is now. If you want to convert the hexadecimal to binary, how to convert? Write the each hexadecimal value in 4-bit format. That is 7. D equivalent to 4-bit value is 1101 and 7 is 0111. Now you have to remember this 3-bit representation of the octal values and the 4-bit representation of hexadecimal values. You have to know that. Okay. If you know that table, then easy. అది గుర్తుపెట్టుకోవాల్సిన అవసరం లేదు. వరుసగా రాసుకుంటూ పోవాలా. ఆ 1 ప్లేస్ మార్చుకుంటూ వెళ్ళిపోవాలంతే. ఇక్కడ ఫస్ట్ 0 వచ్చింది, తర్వాత 1 పెడతాము. ఆ 1 మళ్ళీ ఇక్కడ షిఫ్ట్ అవుతుంది, ఇక్కడ 0 వస్తుంది, మళ్ళీ ఇక్కడ 1 వస్తుంది. అలా షిఫ్ట్ చేస్తూ వెళ్ళిపోవాలంతే. సో యుల్ గెట్ ద hexadecimal equivalent values. Yes, note on make it fast. Break it. 3 cases. పిల్లలు ఉంటే కన్వీన్ క్లోజ్ చేయమన్నారు సార్. 3 cases. మీకు ప్రాబ్లం లేదంటే అడుగుతుంది. అదే మీరు డిసైడ్ చేసేదాన్ని బట్టి ఉంటుంది. అయిపోయింది. నెంబర్ సిస్టమ్ కన్వర్షన్స్ అయిపోయింది. దీని కోర్స్ ఉన్నాయి, బైనరీ కోర్స్ ఉన్నాయి, సిలబస్ లో ఉంది వాళ్ళకి. XHD ఒకటి, గ్రే కోడ్ కన్వర్షన్ ఒకటి. హ్యామింగ్ మీరు చెప్తారా నేను చెప్పాను ఇక్కడ? ఒకళ్ళు అయిందంటే పైన కవర్ చేస్తుంది. కానీ హ్యామింగ్ కోడ్ కొంచెం అదే నాకు మీద మీకు ఇన్స్ట్రక్షన్స్ ఎలా ఉండో దాని వరకే. సైలెంట్ గా ఉండాలి. So I think everyone now you are familiar with the number system conversion for the any number. Not only these 3 number systems, you can, or not only these 4 number systems, you can take the any numbers. But usually in the digital computers are doing the process in only binaries. So we need to understand the binary to decimal conversion, decimal to binary conversion. అంటే మనం కంప్యూటర్ యూజ్ చేయాలంటే అందులో ఏం జరుగుతుందో తెలియాలంటే we need to understand the binary to decimal. ఇవి ఆక్టల్ హెక్సాడెసిమల్ అనేది ఇంటర్మీడియట్. ఆ బైనరీకి డెసిమల్ కి మధ్యలో మీడియేటర్ గా మన ఈజీ కన్వర్షన్ కోసం వీఆర్ యూజింగ్. ఆక్టల్ అయితే వాడము, బట్ హెక్సాడెసిమల్ వీఆర్ యూజింగ్ మోస్ట్ ఆఫ్ ద కేసెస్. ఎందుకంటే మీకు మొబైల్ ఫోన్, ఎనీ వన్ కెన్ టెల్ మొబైల్ ఫోన్ ఫీచర్ ఎనీ మీకు తెలిసిన ఫీచర్ చెప్పండి. ఫీచర్స్ ఆఫ్ మొబైల్ ఫోన్, స్పెసిఫికేషన్స్, ర్యాము, రోము, సైజ్ చూస్తారు. ఇంకా ప్రాసెసర్. మెయిన్లీ ఇఫ్ యు ఆర్ బయింగ్ ఏ న్యూ ఫోన్, యు ఆర్ సీయింగ్ ద ఫస్ట్ వన్ ఈజ్ ద మెమొరీ ఎంత ఉంది, ర్యామ్ ఎంత ఉంది. దాని తర్వాత నెక్స్ట్ వన్ ఈజ్ ప్రాసెసర్ ఏ కంపెనీ, వాట్ ఈస్ ద సైజ్ ఆఫ్ ద ప్రాసెసర్ అండ్ ప్రాసెసర్ ఫ్రీక్వెన్సీ. బ్యాటరీ అది సెకండరీ అది. సో processor size you are looking, right? Processor feeder. Okay. Next, processor size also. There is a 16-bit processor, 32-bit processor, 64-bit processor. 64-bit processor అయితే ఇంకా అడ్వాన్స్డ్. సో మీకు ప్రాసెసర్ ఏది తీసుకున్నా కానీ ఎలా ఉంటుందంటే 8-బిట్ అంటాము, లేదంటే 16-బిట్, 32-బిట్, 64 బిట్ మధ్యలో 48 కానీ 32 ఇక్కడ 32లు 33లు 35లు 26లు 24లు ఉండవు. వై? బికాస్ ఆఫ్ బైనరీ నంబర్ సిస్టమ్స్. 2 to the powers, 2 to the power 4, నెక్స్ట్ వన్ 2 to the power 5 అంటే 32, 2 to the power 6 అంటే 64. బికాస్ ఆఫ్ దిస్ బైనరీ నంబర్ సిస్టమ్స్ ఓన్లీ. దెర్ ఇస్ నో ఇంటర్మీడియట్ 48 అట్లా ఏమి ఉండవు. So now, after studying this number system conversions, how the RAM is designing the read-only memories, random access memories. First class lo meeku cheppan. Semiconductor devices are used in to manufacture, to fabricate the memory devices. There is a read-only memory and a random access memory. Okay, so if you want to design the read-only and random access memory, so what are the electronic components we are using in that? So in that, we are using the flip-flaps. In the to design the read-only memory that are random access memory, there is a RAM or ROM, we are using flip-flaps. The flip-flaps are made up of the logic gates. There is a AND gate, OR gate, NOR gate, XOR gate, exclusive OR gate. Okay, main AND gate or inverter. After that, NAND and NOR gates. Using these gates, we are making the flip-flaps. Flip-flap is the 1-bit storage device. For example, 8-bit data kavalanokondi, you can add the 8 flip-flaps. You will get the 8-bit register or 8-bit memory data. Okay, now these flip-flaps are made up of the logic gates. The logic gates are transistors. The diodes and transistors are made up of semiconductor materials. That is the P-type semiconductor and N-type semiconductor. So that's why the link is established between the electronics to digital electronics. Meeku transistor operation artham avute. Next, how we are designing the logic gate using the transistors. That is called the logic families. Okay, so using that logic, ante transistors use chese to make the NAND gate logic. That is called the one logic family. And after designing the logic gate, then that logic gate we are using the flip-flaps. That flip-flaps we are using in read-only memories and random access memories. Okay, now if you are having any doubt, you can ask me. And those who are in online, if you are having any doubt, you can text me in the chat box. Online students, you can text your doubts in the online chat box, Zoom chat box. And those who are present here, if you are having any doubt, you can raise your hand and ask your guide doubts. Anyone? Okay, now any doubts from previous class to till now? Okay, now wait 2 minutes. So if you are going to write the exams, so what are the how they will ask the questions? While studying for the exam point of view, you can keep your syllabus book and you can read the concept. Okay, for example, the semiconductor materials are there. There is a P-type and N-type. The question on that topic is explain the different types of semiconductor devices or semiconductor components. So what are the different types of semiconductor? The P-type and the N-type. So you have to explain how the P-type semiconductor is constructing, how the P-type semiconductor is forming, and what are the charge carriers, and what are the minority charge carriers, and which type of materials from the periodic table we are choosing. You have to explain. Okay. After that, coming to the PN junction diode, the question on PN junction diode is explain the PN junction diode operation with VI characteristics. So you have to construct the PN junction diode first. After constructing the PN junction diode, then you can explain the operation by applying the bias, battery voltage in the forward bias, in the reverse bias. So after explaining that operation of the PN junction diode under forward And reverse, you have to draw the VI characteristics, model graph, not the exact graph, model graph. And one more point in the PN junction diode, what is the knee voltage? You have to mention that knee voltage or the cut-in voltage. You can underline the what are the new topics or new words are coming in your explanation. You can underline that words. Cut-in voltage, okay, and cut-in voltage equal to 0.3 volt for germanium. You can underline that word, that line, that word. Okay, and that is the PN junction diode. Coming to the GNR diode, there is a chance of getting what are the differences between the PN junction diode and the GNR diode. You have to explain everything. How you are making the PN junction diode, how you are making the GNR diode, what is the difference, and what are the differences in the application of the PN junction diode and the GNR diode and VI characteristics, the under forward bias, under reverse bias. What's happening if you are applying the both forward bias to the both diodes? What's happening in the PN junction diode? What's happening in the GNR diode? You have to explain. That is GNR diode. Coming to the transistors, okay, the different what is the construction and the operation of the transistor. So how the transistor is constructing and the that is how that is operating for the both NPN as well as PNP transistors. Both you have to explain. Now here we are taking only NPN transistor. So in that NPN place, you can use the PNP. Wherever electron is there, in that place you can place the hole, and wherever hole is there, in that place you can place the electron. The remaining explanation is same. Operation also same, and VI characteristic, that is the input characteristics, and the output also same. Okay, coming to the rectifiers. The rectifier, different types of rectifiers you have to understand, and only you can concentrate on the full wave rectifier and the bridge rectifier. Here also there is a asking the question like, what is the comparison between full wave rectifier and the bridge rectifier? If in the comparison, if both are same features, and also you can include different features like the PN full wave rectifier is having the 2 diodes and the bridge rectifier is having 4 diodes. This is the difference. While comparing, you can write the both comparisons as well as the differences. Okay, if they are asking the difference between, then only the differences, not the common points. But in the comparison, you can write the common points also, not only this, the any subject. Okay, that is the full wave rectifier. Now, the application of the GNR diode as a voltage regulator. For that, you have to draw the circuit. The application of the GNR diode comes under your Bloom's taxonomy analysis part, apply part. Okay, in that application, so where we are in the GNR diode and PN junction diodes, you have to explain the applications. Especially the GNR diode as a voltage regulator. Okay, so this is about the electronics. In that electronics, the simple one block diagram is there, public address system and the basic instrumentation system. Simply you can draw the block diagram and explain the each block in few words. Okay, that is enough for the public address system and in the basic instrumentation system. And now you can take this digital electronics. So now we are completed the decimal and number system, different number systems, and user defined number system also we can design now. Your own number system also you can design now. Okay, now the existing number systems, decimal, octal, binary, and hexadecimal number systems. And each conversion to all possible ways. We can convert hexadecimal to octal. New point here. How to convert hexadecimal to octal? Anyone can answer? First, exactly. First, you can convert hexa to binary. Ela convert hexa to binary. The each hexadecimal digit you can represent in 4-bit format. Adi binary equivalent out. Binary equivalent vachin tarvata binary to octal. No, there is no direct conversion between the octal to hexadecimal to octal. But the intermediate ways we are using can get the value, octal equivalent value. Okay. So similarly, octal to hexadecimal also. First octal is there, 3-bit lo rayandi, 3-bit format lo each digit. After giving the binary value, that binary value you can convert to the hexadecimal by grouping the 4 bits as a one group. Okay, that is the all possible number system conversions. Okay, still, if you are having any doubt now, you can ask me. And if you are having any doubt, you can ask in the online also. My number is 9908644747. Your madam will provide. 086444746. If you are having genuine doubt, then only you can text in the WhatsApp. Okay. Thank you. Yeah, that is not topic is not covered. BCD to pure binary. BCD. Okay. Yeah, BCD stands for binary coded decimal. Pure binary. Okay. Pure binary means BCD lo how many bits we are taking? 4 bits. Binary. See, మీకు అది కాలేదు. ఒక BCD value. BCD లో the all numbers are 0 to 9 only. The 0 can be represented as 0, 0, 0. 9 can be represented as 0, 1, 0. 9 తర్వాత BCD value ఏంటి? 1, 0, 1, 1, 1, 2. ఓకే. సో నౌ ఇక్కడ బట్ ఈ 4 బిట్ ఫార్మాట్ లో రాస్తే 1, 0, 1, 0 తర్వాత ఏమొస్తుంది? ఇదే కదా వచ్చి చూడండి అక్కడ 9 తర్వాత 1 తర్వాత 1, 0, 1, 1. నెక్స్ట్ 1, 1, 0, 0. ఇది ప్యూర్ బైనరీ 4 బిట్ ఫార్మాట్ లో. బట్ దీస్ సింబల్స్ ఆర్ నాట్ ప్రజెంట్ హియర్. ఏది? డెసిమల్ లో. ఇది ఎంత వాల్యూ? ఏది? దిస్ ఇస్ ద BCD. ఇది ప్యూర్ బైనరీ. ఇది దీని వాల్యూ ఎంత? ఎంత ఇది? ఇది డెసిమల్ వాల్యూ అమ్మ. BCD అంటే ఏంది? బైనరీ కోడెడ్ డెసిమల్. అంటే డెసిమల్ వాల్యూస్ కి వీఆర్ రిప్రజెంటింగ్ ఇన్ ద బైనరీ ఫార్మ్. అదే ఇది 0 to 9. 9 తర్వాత ఏమొస్తుంది? డెసిమల్ లో ఏమొస్తుంది? డెసిమల్ లో 9 తర్వాత don't say the 1, 0, 1, 1 like that. What is the value? You can tell me. 10. So that 10 equivalent binary value is 0, 0, 0, 0, 0, 1. ఇదేమో 0. అంటే ఒక నెంబర్ ఇంకోటి 2 మీకు 125 ఉంది. ఈ 125 is the డెసిమల్ వాల్యూ. ఈ డెసిమల్ వాల్యూకి మీకు BCD వాల్యూ కావాలంటే BCD అంటే ఏంటి? దీనికి 0, 1, 0, 1. ఇది 0, 0, 1, 0 అండ్ ఇది 0, 0, 0, 1. దిస్ ఈస్ ద BCD వాల్యూ. అంటే BCDకి దీనికి డిఫరెన్స్ ఏంటంటే BCD లో 9 తర్వాత కూడా సింబల్స్ ABCD అని. బట్ ఇన్ ద డెసిమల్ దెర్ ఇస్ నో సింబల్స్. వీఆర్ స్టాపింగ్ ఎట్ 9. సో దట్స్ వై ద నేమ్ ఈజ్ కాల్డ్ బైనరీ కోడెడ్ డెసిమల్. అంటే డెసిమల్ వాల్యూకి వీఆర్ రిప్రజెంటింగ్ బైనరీ ఈక్వలెంట్ వాల్యూస్ అప్ టు 9 ఓన్లీ. ఇంకా టాపిక్ కవర్ కాలేదు. యూ కెన్ అండర్స్టాండ్ ఆఫ్టర్ ఎక్స్ప్లెయినింగ్ దిస్ కాన్సెప్ట్. ఓకే. అది ఆ టాపిక్ యాక్చువల్గా కవర్ కావాలి. అయితే అది కూడా డౌట్ వచ్చేది కాదు.
అడుగుతారు సార్.
Convert, see the questions on number systems. Convert the following numbers into binary. They will give the 625 is the decimal number. Decimal. So convert binary A, binary B, octal C, hexadecimal. So you need to convert that 625 to binary number system, 625 to octal as well as the hexadecimal. Similar to 125 తీసుకున్నాం మనం. ఆ 125 3 లో కన్వర్ట్ చేసిన 3 నెంబర్ సిస్టమ్ లోకి అలాంటి క్వశ్చన్స్ అన్ని వస్తాయి. లేకుంటే కన్వర్ట్ ద గివెన్ ఆక్టల్ నంబర్ టు హెక్సాడెసిమల్ నంబర్ సిస్టమ్ అలా కూడా అడుగుతాడు. వాడు కన్వర్షన్ ఇస్తుందంటే బ్రాకెట్ లో మీకు నంబర్ ఇచ్చి దాని కింద సఫిక్స్ దాని బేస్ వాల్యూ యాడ్ చేస్తాడు. ఓకే. కొన్నిసార్లు కన్ఫ్యూజ్ చేయడానికి ఏంటి, నేను స్టార్టింగ్ లో ఒకటి మిస్టేక్ చేశాను కదా, వాంటెడ్ మిస్టేక్. అదేది 128 రాసి దాన్ని ఆక్టల్ నెంబర్ అన్నాను. సో దట్ ఈస్ నాట్ ఆక్టల్ నెంబర్ బికాస్ 8 ఈస్ నాట్ ద సింబల్ ఆఫ్ ఆక్టల్ నెంబర్. దట్ ఈస్ ద రాంగ్ క్వశ్చన్. అంటే కన్ఫ్యూజ్ చేయడానికి దే విల్ ఆస్క్ సచ్ క్వశ్చన్స్. సో యూ హ్యావ్ టు ఐడెంటిఫై అండ్ యూ కెన్ ఎక్స్ప్లెయిన్ దట్ క్వశ్చన్. ద క్వశ్చన్ ఈస్ రాంగ్ because the 8 is not the symbol of octal number. Any other questions?
Sir, what is evolution of electrons?
Evolution of electrons. Okay, sit down. Evolution of electrons means what is the first electron semiconductors are introduced. In the first class, we discussed that is the 1904 vacuum tubes. There is no semi tubes. If you want the vacuum tubes, I will draw the vacuum tube symbol. Time up. If you are taking the vacuum tube, so now here the filament we are taking here, for this filament we are applying the voltage. So now due to this voltage, the filament will generate the electrons. How the n-type semiconductor is having the majority charge carries an electrons. Now that filament will generate the electrons. Now that electrons can move depending on the applied voltage. So there is a vacuum tube. That vacuum tube size may be this much. Simple diode size. So there is a diode. Thermionic diode. That is called the thermionic diode. So now 1904. In 1907, triode. Triode means 3 ions. Here 2 ions. In that 3 ions. After 1904, in the 1944, what is the 1944? IC technology. IC, not IC, the transistor. When is the introduction of the transistor? 1944. In the 1947, the all vacuum tubes are replaced by the solid state devices. The all vacuum because of this size. మీకు ఫ్లాపీ చూసారా ఎవరన్నా? ఫ్లాపీ డిస్క్. సిడి చూసారా? సిడి కన్నా ముందు ఫ్లాపీ ఉండేది. దాని సైజ్ ఎంతో తెలుసా? 4 MB. 4 MB అంటే మీ చిన్న అదేది షార్ట్ ఫిల్మ్ లో షార్ట్స్ వస్తాయి కదా, దాని సైజు 2 minute వీడియో ఆర్ 30 seconds వీడియో. ఆ 30 seconds వీడియో కూడా 10 MB 20 MB లో ఉంటుంది. అంటే ఆ సైజ్ అంతకన్నా సైజ్ తక్కువ మెమరీ డివైజెస్ ఉండేటివి. అవి బికాస్ all are replaced with the our semiconductor. So in the 1957, the IC technology was introduced. 1952 and 57, IC technology, that is the integrated circuits. In the 1974, the nanotechnology. Because of that nanotechnology only, we are getting our components, the laptops, desktops, our mobile phones, or size is decreased. So that is the, you can write the evaluations when the triode, the vacuum tube is introduced, invented. After that, when the triode is invented. After that, when the transistor invented. And who invented the transistor? Their scientist names. Okay, and IC technology and nanotechnologies. That is the evaluation of electronics from vacuum tubes to nanotechnology. Okay, so there is the evaluation of electronics అంటే ఏంటి? ఎప్పుడు ఏ డివైస్ ఇన్వెంట్ చేశారు? Who is the scientist and what is the year? You can write that question, answer for the electronic evaluation. Any others? అంటే వాళ్ళకొకరికి చెప్పలేదు ఆన్సర్. మీ తరపు నుంచి ఒకరు డౌట్ అడిగారంటే అది అందరికీ యూజ్ అవుతుంది. సో యూ కెన్ ఆస్క్ యువర్ డౌట్ అండ్ యూ కెన్ హెల్ప్ యువర్ ఫ్రెండ్స్. మీరు ఖాళీగా కూర్చుంటే వేరే వాళ్ళు కూడా నాలెడ్జ్ గెయిన్ చేయరు. ఇది డిస్కస్ చేసి ఒకవేళ మీరు మర్చిపోయి ఒకవేళ మీకు ఇంకా మైండ్లో ఏమైనా డౌట్ ఉంటే కూడా యూ కెన్ ఆస్క్ ద క్వశ్చన్. ఎనీ క్వశ్చన్స్? ఓకే, థ్యాంక్ యూ ఫర్ యువర్ పేషెన్స్ bearing 2 days session. Okay.